Good morning. Please pause the video and get out course pack page 314 and 315. I'm going to go and do 3 examples for you. We're first going to start with the factor theorem. The factor theorem tells me that a polynomial f of x has factor x minus k if and only if f of k equals 0. What this tells me that if my remainder after synthetic division is 0, then x plus 3 is a factor of f of x, and more to the point, negative 3 is a 0, a root, an x-intercept. The point negative 3, 0 is on the x-axis. So let's try example 1. F of x is equal to x cubed minus 3x minus 13x minus 12. I want to factor out x plus 1. Show that the binomial is a factor of the polynomial. Then factor the function completely. So I'm first going to start by putting in the box x plus 1's my factor. So my 0, what goes in the box, is negative 1. My coefficient for x cubed is 1. My coefficient for x, well, I need a coefficient for x squared. That's 0. My coefficient for x is negative 13. And my coefficient for the constant is negative 12. I am then going to draw my line, and I'm going to get my first drop down my leading coefficient. Negative 1 times 1 is negative 1. 0 plus a negative 1 is negative 1. Negative 1 times negative 1 is 1. Negative 13 plus 1 is negative 12. Negative 1 times negative 12 is 12. Negative 12 plus 12 is 0. So 0 tells me that it's a factor. I now know, since this was x cubed, that this is x squared, 1x squared, minus 1x minus 12 times x plus 1 is equal to my original function, x cubed minus 13x minus 12. But this is telling me to factor completely. So now I need to take this next part, x squared minus x minus 12, and factor. Well, this is basic factoring. What multiplies to be negative 12 and adds to be negative 1? I'm getting negative 4 and 3. So then this factors 2. The x plus 1 is still there. This is x minus 4 times x plus 3. This is now factored completely. And this is my solution. I want to do one more of these so it makes sense to you. I'm going to do part C. So again, I want to show the binomial is a factor of the polynomial, then factor completely. To show that it's a factor of the polynomial, I'm going to do synthetic division. X minus 5 is my factor, so I am going my binomial. So 5, the opposite of this, goes in the box. My coefficients start off with x to the 4th is 2. X cubed is negative 12. X squared is 6. X is 20. And then my constant term is 0, since there isn't a constant term. So again, I'm going to draw my line, and I'm going to go ahead and I'm going to drop my leading coefficient. 5 times 2 is 10. Negative 12 plus 10 is negative 2. 5 times negative 2 is negative 10. 6 minus 10, or plus a negative 10, is negative 4. 5 times negative 4 is negative 20. 20 plus a negative 20 is 0. 5 times 0 is 0. 0 plus 0 is 0. Because my remainder is 0, I know that x minus 5 is a factor. So I can say that 2x to the 4th minus 12x to the 3rd plus 6x squared plus 20x is now equal to my factor x minus 5 times what I have remaining. This started out as x to the fourth, so this is 2x to the third minus 2x squared minus 4x plus 0. Well, I'm not going to worry about the plus 0. So now I've factored out this first factor, x minus 5. I want to now factor completely. If I look at these three terms, I have a greatest common factor of 2x. So if I factor out a 2x, I get x squared minus x minus 2. I'm going to move that 2x to the front. 2x times x minus 5 times x squared minus x minus 2. So then I have 2x times x minus 5. What multiplies to be negative 2 and add to be negative 1? Well, that's negative 2 and 1. So then this is x minus 2 and x plus 1. There are my factors, and now it's fully factored. Let's go ahead and go to example 2. Example 2 is now telling us to solve a polynomial by factoring. It's just like solving a quadratic equation by factoring. Once I get my factors, I want to use the zero product property to let each factor equal 0. So I'm going to just do this first example 2, and I'm going to take out a greatest common factor of x. So I'm going to get x, and this becomes 2x squared. Pause and get out page 315 if you haven't. Divide this by x, I get negative 12x. Divide this by x is plus 18 is equal to 0. I factored out an x. It needs to stay there. I have 2x squared plus minus 12x plus 18. Well, the question is what multiplies to be 18 and adds to be negative 12? Well, let's see, it's 1 and 18. That is 2 and 9. Well, I goofed, so I'm going to back up. I need to start all over because I actually have a greatest common factor of 2x. And that's why it wasn't working for me. So this would be x squared minus 6 plus 9 is equal to 0. What multiplies to be 9 and adds to be negative 6? Well, that's going to be negative 3 and negative 3. So this is 2x times x minus 3 squared, or x minus 3 times x minus 3, and that's equal to 0. I then have to say that 2x is equal to 0, so x is equal to 0. I have to say x minus 3 is equal to 0, add 3, and x is equal to 3. And finally, x minus 3 is equal to 0, so x is equal to 3. 3 is a solution twice. This is called a double root. So this tells me that my zeros are 0, 3, and 3. If I was graphing this, my zeros would be at 0 and 1, 2, 3. If I look at my leading coefficient, it's positive. If I look at my degree, it's odd. So this is going to be positive Egyptian. So my graph is going to look like this. So when I go to graph this, I'm going to start low. I'm going to go through this as 0. I'm going to come back down. Since this second 0 is a double root, I'm going to touch the vertex and go away. I went a little too straight up there. But because this is a double root, it touches it and goes back up. That's what it means to be a double root. It doesn't go through it. It comes down, touches it, and goes back up. And that's what that graph would look like. This didn't ask me to graph, but the next one's going to. So the solutions for this were 0 and 3 was a double root. And so finally, number 3 says find all zeros of f of x equals negative 2x to the fourth plus 16x squared minus 32. Then sketch it. So again, this looks quadratic form. This is a 4. This is a 2. The 2 is half of 4. I'm going to take out a greatest common factor, or a common factor of negative 2. That's going to leave me with x to the fourth plus 8x squared minus, or I should say, since I took out a negative, this would be negative 8x squared plus 16. I want to find my zeros, so I'm going to let it equal 0. And I'm going to factor this middle part as if it was a quadratic. So what multiplies to be 16 and adds to be negative 8? Well, that's negative 4 and negative 4. So this becomes x squared minus 4 times x squared minus 4. And this is equal to 0. Well, then I divide both sides by negative 2, and I get x squared minus 4 times x squared minus 4 is equal to 0. Well, these are identical, and again, I'm going to end up with a double root. So if I go to the side over here, I can say that x squared minus 4 is equal to 0, add 4. X squared is equal to 4 square root. X is equal to plus or minus 2. Well, I'm going to get that for both of these. So that means positive 2 and negative 2 are both double roots. When I go then to graph these, I have positive 2. I have negative 2. They're double roots. My leading coefficient is negative. My degree is even. So this is strongman. It's going to be facing down. Because these are double roots, I'm going to touch them and go back the same direction. I'm going to start low on the left, touch my 0, come back down, come back up on the right, touch my 0, and go back down. And that's how the graph would look like, somewhat. If I look, I'm going to have a y-intercept of negative 32, so technically that would be negative 32. But those are the 3 examples of what we haven't covered so far. Have a good day.